This is video 3 for paper 3 of the mock exams. In this video we're going to start off by looking at finding the median, or at least in this case the class that the median lies in. Well, the median is the middle number, so the first thing we would have to do is work out how many people that this little survey actually represents. So we would do that by adding together all of the numbers in the frequency column. So here we would get 150. To find the middle person, if you remember back to the stats exam, what we have to do is 150 plus 1 divided by 2, and that tells us the position of the middle person. So here 151 divided by 2 gives us 75.5. In order to find where the 75.5th person is, what we would do is think, have we got up to 75 in that first group? No, we've only got up to 38. Add on the next group, that would get us up to 74. We've not yet hit 75.5. If you add on the number of people in this group, that takes us up to 104. So yes, they're in this group. So the class that contains the median would be 25 up to 40. For the next topic, we're looking a little bit at area, but we are going to use a bit of algebra within this question. So here what it wants us to do is to show that the two shapes have the exact same area. So in order to do that, what I'm going to do is try and work out the area of both of them, obviously in terms of x. So for this one, I would need to do 5 multiplied by 2x minus 2. 5 times 2x is 10x, minus 5 times 2 is 10. So I've just times 5 by both bits there inside the bracket. For this one, we would need to do two different sections. So here I would do 2 times 3x to give me 6x, and 2 times minus 1 to give me minus 2. And then the same down here, 4 multiplied by x gives me 4x, and 4 multiplied by 2 gives me minus 8. If I now add these two bits together, 6x plus 4x is 10x, minus 2, take away another 8, is minus 10. So we have proven here that the two areas are the same. The next topic also has a little link with area, but on this case we're actually looking at area of something called similar shapes. Now if you remember, similar shapes are shapes that are exactly the same, they have just been enlarged. So in this example, the area of this shape here is 24 centimetres squared. If this side here is 2, that tells me that this side here is 12. 2 times 12 makes 24. Now if you notice, the scale factor for this shape compared to this one is 3, because I would need to multiply this side by 3 to make 6. So here I'm multiplying that side by 3 to get the larger shape. So I would have to do the same to the other side as well. So I'd times that one by 3 to make 36. Now if I work out the area of this shape, so in other words if I do 6 times 36, this gives me 216 centimetres squared. Now if you notice, the scale factor for the side was 3. However, the scale factor for the area, 24 times 3 does not equal 216. What we've actually got here is that we have times the area by 3 and by 3 again. So what we get is this. The scale factor for the length of a side is 3, or times by 3. But for the area, it is actually 3 times 3 again. So 3 squared, which in this case is 9. So here, where it's asking me for a calculation to find the area, we would have to do 24 times 3, which is a scale factor, squared, because this is how we would do the scale factor for an area. The final question in this section is this. Now initially, this question looks like it's just going to be a case of trial and error with some numbers. However, if we take a bit of an algebra link to this, what we can do is form some equations. So if I'm thinking of two numbers, I don't know what they are at the moment, or at least I do, but nobody else does. What I'm going to say is let's call the first number x, and let's call the second number y. So if we're using this first section, it says if I multiply my first number by 5, so I'd write that as 5x, and then add my second number, so add y, because that's the letter I use for my second number, the answer is 32. So it equals 32. Now let's write a second equation for this second paragraph. If I multiply my first number by 3, so that would be 3x, and then add my second number, plus y, the answer is 21. So what we have done here is we have formed simultaneous equations. So at this point, because both have the same number of y's, I then start thinking about DAS. We're looking at the symbols, remember, different add, same subtract. Both are pluses, so I subtract. 5x take away 3x is 2x. The y's will cancel each other out. This is why we've done this process. And 32 take away 21 would give me 11. 2x is equal to 11, so x would have to be 5.5. I now need to find the value of y. What I do is I substitute x equals 5.5 into one of these equations. I'm going to use this one at the bottom here. So what I'm going to do, take this equation over here, is I'm going to replace the letter x with the number 5.5 in this equation. So it becomes 3 times 5.5 plus y equals 21. So 3 times 5.5, remember calculator paper, is 16.5 plus y equals 21. So I'd need to do 21 take away 16.5, which would give me y is equal to 4.5.